am 303. Warning, this process is dangerous. Do not attempt without proper precautions. Hello friends, welcome back to my channel. In this little box here, I have a couple pieces of gold-plated jewelry that were featured in my gold types video. There's an earring and a bow tie lapel pin, I guess. I'm going to do a complete refining to find out how much gold is actually on these two pieces. First, I'm going to get a weight. And altogether, it looks like it weighs 10.78 grams. In the gold types video, I said that I thought that these two pieces were filled with a zinc-based material. I made a couple of cuts into these pieces to show the inside for the gold types video. This little piece here is some type of enamel or plastic that's on the earring piece. I guess it's supposed to look like onyx, but it's plastic. And this is a little piece that's cut off of the bow tie thingy. And this is a little piece that's cut off of the earring. The little point here looks like a different material than the inside, like that is a part of the plating that's separated. So now I'm going to cut them up into tiny pieces. Here you can get a good look at the base metal in the middle, and also the back came separated, and interestingly enough the back is made of a different material. Here's the earring piece all cut up, and all the enamel came off except that bit in the middle there. There's all the plastic enamel pieces that I separated. Those will just go right in the trash because they don't have anything good on them. This little pin here is from the back of the bow tie, and now we'll cut the bow tie up. Okay, so I'm going to leave the back of the earring separate for now, and I'm going to weigh all these zinc-based pieces. And we got 976,977 grams, so we lost about 1 gram between this back thingy here and the plastic enamel pieces. So I scratched at this for a minute, and some of the outside layer came off, and I was hoping that it might be copper in the middle so there would be a huge contrast, but it really looks like it might be brass in the middle, so there's not much of a contrast between the plating on the outside. So I'm going to pick up the paper that I was working on and get all the little bits into this beaker here. And then I'll put all of this in the beaker as well. And then we'll take it outside. Now, since it's zinc based, we're going to hit it with some hydrochloric acid. That's a little bit out of the shot there, but you can see when the acid goes in, there's an immediate reaction. We let that sit for a little while, and then here we added 20 milliliters more of hydrochloric acid, and you can see there's still a reaction going. Probably not as vigorous as it was before, but it's still happening. So I let it sit like that for about an hour, And then when I came back, it was this milky white color, and I decided to put it on the super scientific hot plate to speed things up a little bit. When the heat increased, so did the reaction. And just a side note, I hydrated this with just some regular tap water a couple of times during this process. So here it looks like a lot of the base metal from the middle is getting dissolved, and it's really just shells left behind that didn't get dissolved into the hydrochloric acid. Gold, copper, and silver would definitely be left behind because they would not dissolve into the hydrochloric acid. They do appear to look kind of gray here, but with the naked eye, you can see what looks like little specks of gold clinging to the outside. Now the reaction is complete. Before I shot this, I added a little bit of hydrochloric acid just to make sure that we weren't getting anything else dissolved into the solution, and it appears like it's negative. So I'm going to take this filter here and collect all of the pieces and clean this beaker out and go on to the next step. So I have a brand new melt dish here that I seasoned with some borax, and I'm going to take these shells and put them in the furnace. If I was trying to be efficient, I could have skipped this step. The reason why I did this is because I wanted to see what those shells weighed compared to the whole thing. Plus, I really like to use my furnace. I took it out of the furnace here and seasoned it with a little borax, and then I'm going to throw it back in the furnace and turn it back on. The little piece of metal is starting to freeze, so I'm going to try to pull it out with the tongs and quench it in some water. It's really covered in a lot of borax. It has a really nice gold color. I would like to say that this is the gold and in the video here, but that would be fake. I know that's not pure gold. A lot of times when you're melting metals that contain gold, when you first take them out, they will have a gold appearance, especially on the bottom if you take them out in a solid piece. It probably means there's gold in there, but maybe not that much. So there's some water in that beaker, and we just added sulfuric acid, and we're going to turn it on and try to boil off some of this flux. Okay, now it's out, and we're going to try to weigh the thing. All right, there it is with no flux, and it looks a lot more like copper than it does gold now. And the weight is about 0.88 grams. Now we got it back on the hot plate in some distilled water, and we started out with like 4 milliliters of 68 to 70% nitric acid to see if we can get this gold separated from whatever other metals are in there. When you see those little tiny hydrogen bubbles, you know that something's getting dissolved into your solution. Now here the solution has turned blue, indicating that we have a copper nitrate solution. So we took off the blue liquid and started with some fresh here. So we have about 20 milliliters of distilled water and about 4 more milliliters of nitric acid. And you see there's a vigorous reaction starting now. Our little bead is continuing to get smaller, but you can see here in the middle of the beaker there is a cloud of black sediment, which is hopefully our gold. Now the solution is turning blue again, and you can see that our button is continuing to get smaller. Here's a close-up of the little guy dancing around as he's getting dissolved and smaller and smaller and smaller. Now he's completely gone. Everything except the little pile of black sediment in the middle. So we're going to put both blue solutions together because in the original solution, it also has sediment that settled out into the bottom. Okay, so now we're going to run the blue solution through a vacuum filter to see if we can gather all of that fine sediment out of the bottom. While this is running, I wanted to mention that the expected yield for gold-plated items in general usually averages out to be 0.05%. So if this was dead on average and we started with 10 grams at 0.005%, that would be 0.005 grams or 5 milligrams. So really, this is totally not economically feasible. In fact, the filter disc that I have in this filter probably costs more than this gold is worth at 5 milligrams. Doing this video and going through this process is worth it to me, even though the amount of gold that I'll get is not very much. But on the plus side of things, I will get some gold out of it to add to the gold that I'm working on. Okay, so now we've got it all run through and rinsed down, and this is what we're left with. It's really purple. So now we'll put our filter disc down inside of a beaker and dissolve it in some acid peroxide solution. We'll start off with some hydrochloric acid. And then we'll add some 3% hydrogen peroxide. It's so finely powdered that I think the 3% will work just fine. Now we're going to transfer the solution into a 100 milliliter beaker. Here you can see it looks yellow like it's supposed to, but we're going to rinse out the filter in the other beaker with some more peroxide, and that'll make it turn a little bit whiter. So then we'll try to cook it down till we get it back to where it's yellow again. So hopefully we can take a stannous test after that. Now it's starting to look that familiar yellow color again. This is the copper nitrate solution that we filtered off, and I'm adding some hydrochloric acid to it to see if there is any silver chloride formed. I don't see anything, so I'm calling that negative. Okay, here's our solution. We got it cooked down to about 10 milliliters. It looks really yellow. We're going to try to give it a quick stannous test. At first glance, I would call that negative, or at least inconclusive. Sometimes stannous tests are easier to read when you dry them out, so I thought I would hover it over some heat to see if I could get it to dry. Not being deterred by the negative stannous test or inconclusive stannous test, I wanted to continue this. The solution was kind of cloudy, so that may be where all the silver in this gold-plated stuff was in the form of silver chloride in my acid peroxide solution. So now that it's filtered out, I'm going to add a little bit of sodium metabisulfite in the form of stump out. That should be more than enough to drop this out. It's probably enough to drop out about 1 gram. Since the solution was really clear, there was no color change, so I decided to let it sit overnight, covered with a watch glass. In the morning, I ran it back through the vacuum filter, and this is what I got. So this is all the gold, and you can see the stannous test from last night appears to be a little bit dark. There are a couple of larger pieces on here, and some nice caramel colored gold powder. The result is in milligrams, so I don't have anything accurate enough to weigh it. Thanks for watching. The end.